Hi, my name is Mitch and I'm the project engineer for MGCom. The project is to deliver 11 sites to Charles Sturt University. The prototype will deliver 3 MPLS nodes along with 2 branch sites which represent Albury and Dubbo campuses. Alright, so we'll just log into the Albury Provider Edge router, part of the MPLS core. As you can see, we logged in there to the MGCom router. A little warning banner there, logging in as user MGCom. Now we're going to show interface descriptions. It just shows us that there's a WAN interface as well as a LAN interface. No, sorry, that's an interface facing the branch office. Gig001 is facing Charles Sturt University in Albury. Now we're moving on to showing the BGP neighbors, and I've just sorted it by 172 loopback addresses to weed out some of the unnecessary information so it's not too verbose. Now we're going to show OSPF neighbors. In the global table or in the OSPF neighborships, it's just simply the neighboring MPLS router. But we can also go do show OSPF neighbors in the instance CSU, and it'll show the customer site router, which is r0.csu.alb. Now we're just doing the VRF routing table, or the routing instance, virtual routing instance table, which is the CSU INET table. And then we have the loopback addresses at the top, the first 2. And then we have the LAN routes for the Dubbo site, followed by the LAN routes for the Albury site, and then the WAN interfaces, which are represented by 192.168.101 in the third octet. They're all there, and as you can see, they're learnt by OSPF. Now we're just going to SSH inside of the routing instance down to the customer site router, which is r0.csu.alb. Logging in again with the MGCom banner, security banner there, the warning when you log in. Just a show version there, show the platform. It's a Juniper SRX 220H. The Junos code is a little bit out of date, but that will not slow us down at all in this lab. Just the show interfaces terse, the IP address allocation to each interface. Got the major interface, the gig000 is the WAN, followed by the VLAN interfaces. There we go, showing all the routes learnt by this router. Again, it has the loopbacks, the LAN routes, and the WAN routes all there, mostly learnt by OSPF. Just going to prove connectivity across the core, and that's pinging the WAN address over here of the Dubbo router, 192.168.101.30. Moving right over to the Bathurst core router. Logging in again as user MGCom, MGCom being the fictitious firm created for this project only. just showing the participation in BGP, showing the loopbacks of both sides, Albury and Dubbo, neighbourship, and the mock AS of 5.5s. I'm going to go ahead and check the route table for CSU, and because it is peered, with the other two that have learnt the routes, it has imported those routes to the table, to the CSU INET table. The OSPF neighbourship again shows the MGCOM provider routers, Albury and Dubbo. But if we are to go like this into neighbour OSPF neighbour instance in CSU, it doesn't have one because the prototype isn't showing the Bathurst campus. So we'll move right along to the Dubbo router. Logging in again with MGCOM. User. Just wait for it to load. And just going to again check the neighbourship. So it's got the Bathurst router there in the OSPF table, and this one of course has the Charles State University campus in Dubbo, OSPF neighbour with it in the CSU routing instance. And we just jumped onto the Dubbo campus router. We'll go ahead and check the interfaces on this device. There we have the routes. And we'll go ahead and just do a ping test. Over to the LAN, it's the data VLAN in the Albury campus. There's a physical representation of the lab. 3 SRX240s in the middle, Juniper SRXs. We've got SRX 100 at Dubbo and SRX 220 at Albury. And the client's connected on each side of the laptops, and they're able to reach each other on LAN. Hope that shows you what we're working with, and thank you very much.